by the end of this first problem to tell me how this equation relates to what I'm talking about today. So there is a relationship. I want you to find it. Okay, on the top of page 172, I want you to copy down that table that's in green headings. And you don't have to spell everything out, but this is what you do need to have. 3 columns. First column, second column, and third column. You have your day. You have your ticket sales. And what's the last column? Yes, revenue. Yep, that's how much money someone made, or this company made, or this person made. All right, so the 3 days were Friday, Saturday, and Sunday. So, do you notice that they give a variable to the ticket sales? What's the variable they gave to the ticket sales? X variable. What did they give to the revenue? Y. Okay, so I have my 3 rows, and I put Friday, Saturday, and Sunday. Okay, how many ticket sales do they have on Friday? Sorry? 205? Okay, so ticket sales were 205. How much money did they make off of that on that day? Sam, how much money for revenue on Friday? $615. Okay. All right, on Saturday, how many tickets did they sell, Henry?
310.
310. And how much revenue did that bring in, Natalie?
Well, I can find my text.
Okay. That's all right. Make sure, okay, if you have your book, make sure you turn to page 172. Drew, what's the amount of revenue for Saturday?
130.
Okay, and then Sunday, Sam, how many tickets were sold?
170.
170. And then revenue on that day, Lana?
I forgot. Wait, 510.
510? Okay. So we just filled in the chart. Hopefully you have all that info. Okay. Now, what I want you to get here is that there are 2 columns of numerical info. You have ticket sales and you have revenue. And they depend on one another. They're related to one another. But what we're looking at today is if they have a direct variation. Okay, so what I'm going to do is I'm going to give you an equation, and I want somebody to relate it back to that equation. Okay, so here's your direct variation equation. Y equals kx. So write that down, super important. In fact, some of your answers need to be in that format, so I would memorize it. Okay, Brad, what's one similarity with this equation and that equation? What's one thing?
Y is by itself.
Good. Y is by itself, so I got y equals something and y equals something. Good. What's another similarity? Eva, what's another thing that's the same?
MX and KX.
Yeah.
Different letters.
Okay, you have m multiplied by x. You have k being multiplied by x. That's another similarity. And there's also another similarity that doesn't look like it's there. What does B stand for, I said, Gracie? B?
The
Y-intercept. Now, does this have a B value?
Yep.
Someone said yep, and it's correct. This has a B value. Close. It's plus 0. Don't write this in. Don't write this in. It's plus 0. So here in the slope-intercept form, B can be many things. It can be positive 30, negative 15 over 2. But in these equations, what's your y-intercept always going to be? 0. It's always the same thing, which is nice because I don't have to figure it out. Okay. These two are very similar. I would say they're the same. What does m equal over here? Someone said it. M equals slope. And what does slope equal here? K. K and m are the same thing. Now, why do we call it different? Why do we have different variables? We'll see in just a moment. Okay, this is what I want you to do on this problem. I want to find that slope. I want to find out what is k worth. There you go. What is k worth? So how do I do it? I'm going to work this problem out 3 times, and I need you guys to work it out that many times for these problems because you need to find out what K is. Okay, I gave Y as the revenue and X as the ticket sales. Do you guys remember independent and dependent variables? How many of you you recognize those terms? Independent variable, dependent variable? Okay, you should all because you all have had it. This is what I'm going to ask. Please answer the question wisely. Do the ticket sales depend on the revenue, or does the revenue depend on the ticket sales? Which way is it? Good. Revenue depends on the ticket sales. I agree with that. So listen, if you need to write this down because you will forget this, the revenue is dependent on the ticket sales. Y is your dependent variable. You need to get that down. Like if you didn't write it down, you need to have it up here. Y is dependent on X. X is your independent variable. So X doesn't need Y, but Y does need X. And you're going to have to figure out which one's independent, which one's dependent on your problem. So I hope you understand that the money someone makes in this company is based on how many tickets they sell. It's dependent on how many tickets they sell. Okay. Looking at the first row here. First row. What's my Y value in the first row? 615. It's the dependent variable. What does my X value equal, therefore? It's the 205. So instead of Y, I'm going to put 615, and instead of X, I'm going to put 205. How do I find out what K is? How do I solve for K? I hear people, 205. You divide both sides by 205. And thankfully, guys, most of these are going to be whole numbers. So what's 615 divided by 205? 3. You know what my K value is equal to? 3. Let's see who was paying attention, at least at just a little bit of attention. Natalie, what's my slope? Sorry, is that causing some stress? Brad, what's my slope? Go. It's 3. Because what does K equal? It equals M. They're the same thing. So on my graph, if I were graphing this, I would go up 3 over 1, up 3 over 1, up 3 over 1. That's my graph. That's my slope. Okay, so you guys okay with that? K is your slope. Why do we call it K, though? Okay, here's what I want you to get. Write this term down. It's a constant of variation. That is kind of what we call like a, it isn't, but it sounds like an oxymoron. Does anyone know what an oxymoron is? It's not a moron. It's an oxymoron. Yeah, it seems it's some word or statement or definition that seems to contradict itself. Okay, constant means it doesn't change, right? Variation means it does change. So it's a non-changing, changing thing. Okay, does that sound weird to some of you? Yes, it should sound, because it's like, wait, how does that work? Okay, what it means is this. This K value, which in our case is 3, is a constant. That means it is a number that doesn't change. But what does that change represent? It changes how this graph moves. And it always changes up 3 over 1. What does it change the next time? Up 3 over 1. What about after that? Up 3 over 1. So it's a constant. It doesn't change in value. But that tells me what the variation is, what the change in the whole graph is. And you're like, wait, how do you know that? I'm going to erase this. Don't erase this work. Just put the next part under. I'm going to do it for the second day, Saturday. What's my Y value on Saturday? 9:30. What's my X value on Saturday? 3:10. How do I find out what K is in this equation? Divide both sides by 310. And does anyone know what I get when I divide both sides by 310? 3. Isn't that a constant? Isn't that a constant? But it tells me how this changes. You constantly are changing the same way. 3 equals k. Okay. But look at Sunday. What looks off about Sunday? You got Friday, you got Saturday, and then you get Sunday. What's wrong with Sunday? Anything?
The numbers go down.
Yeah, the numbers went down. But did they go down according to a constant? Are they constantly changing in the same way? Okay, so I'm going to put for Sunday, y what? 510. What's x? 170. How do I solve for k? I feel like I've done this before. What do I get for k? Did that constant of variation change? No. Does anyone want to tell me what 3 also represents? Like practically, think of this scenario. Tickets sold, revenue made. What's $3 also represent? Think if you're like a business, what does the $3 represent? Ooh.
For every ticket sold.
Costs how much?
$3.
Every ticket is worth $3. You sell 1 ticket, how much money did you make? $3. If you sell 3 tickets, how much money did you make? $9. It goes up by 3 every time, doesn't it? That's a constant of variation. That's what we're talking about. Okay, so this is what you're going to have to do. Once you come up with that constant, and it has to be the same for all 3 scenarios. It has to be the same thing. Well, when you come up with k equals 3 in this case, this is what your answer needs to look like. Y equals 3x. That's your final equation. That is the direct variation equation. What does 3 stand for again, Alex?
The constant of variation.
Good. And it also stands for what, William? This hurts after a while. Please make me stop. Slope. Thank you, whoever helped them out. So y equals 3x. What's the y-intercept on this graph?
0.
0. Yeah, it's over here, plus 0. And you're like, well, why do you keep saying plus 0? Okay, if I were to sketch a graph, it would start right here at the origin, and it would go up in a certain way. It'd go up 3 over 1, up 3 over 1, okay? Do you think I go into the negative territory? What do you think? Think tickets sold. Did I sell minus 5 tickets and make negative $15? Is that how it works? No. So we don't need this direction. Your y-intercept is 0, and you go up to the positive direction, hopefully. Okay, that's a lot of info for one problem, but don't worry, you only have 3 of those. Okay, let me give you another problem here. Look on page 173. Yes, 173. And I want you to look at number 1. Just look at number 1. And you don't have to copy the whole chart down, but I do need to get 2 parts in that chart down. Okay, what are the 2 things being related? What are the 2 variables representing? Yep.
Distance and time.
All right, distance and time. There are 2 things here, distance and time. You have to assign them with the x and the y value. Okay, you have to give them x and y value. Does it matter? Yes. X is which variable? If you have it written down, or it's independent, and y is going to be dependent. And this is how I figure it out. Here's the question I ask. Is the distance traveled dependent on the time, or is the time dependent on the distance traveled? I heard maybe 3 people.
The time is dependent on the distance.
Come on, bold people, say something.
Time is on the distance.
The distance is dependent on the time. The distance is your y variable. Your time is your x variable. Time does not depend on distance. Distance does depend on time. And you're like, wait, how does that work out? Okay, ready?
You do the opposite of what's actually.
No, you just think, does time go without, like, does time go on without distance? Like, can I stay here and time goes on? Yeah, is that true? Like, ready? Did I travel anything in the last 10 seconds? 1, 2, 3, 4, 5. No, I mean the earth and all that, but me on this earth, no. All right, when I travel, I'm moving, right? What else is also moving?
Time.
Time is moving, right? So who's dependent on what? Distance depends on time, not time on distance. Let me give you a hint if you're like, wait, what? Okay, here's a little hint. If time is one of the variables, it's almost always the independent variable. It's the x value. Time doesn't depend on things. Like time is going to move whether you sit there or whether you move, right? So time is independent of distance. So time is x, distance is y. Does that matter? I think it does. Okay, let's look at number 1. And now you know which one's distance, or sorry, which one's y, which one's x. So now I need to do this scenario 4 times, but I'm going to write this down here. And somebody tell me, I want to find out what k is. Does anyone know what I've been doing every single time for k? Does anyone know what I've been doing every single time so far to find out what k is? What am I doing?
You just leave it alone and fill out like the other.
Oh, fill out the other two? And then what do I do with those other 2 numbers? I did what? I divided them? What did I divide?
You divide
X
the
by
X
Y.
value.
X by both sides.
Well, the X value.
This is what you've been doing. I know, this is tough. To solve the k, you've been dividing both sides by x. Is that what you guys are saying? Divide both sides by x. So you've been doing this. You've been dividing whatever y is by x, right? You took this number and divided by what? That number. So you're just doing y divided by x, and you're like, that doesn't seem right. Well, it helps your math to become a little bit quicker. Okay, looking at number 1, looking at the 90 and 3, which one's the y value? The 90 or the 3? The 90. That's the dependent variable. What's your x value? 3. What's 90 divided by 3?
30.
30. What's your k value? 30. It's 30. Yeah, good. Okay. K is 30. The constant variation is 30. So in this case, you go up 30 over 1. That's your slope. It's really steep. Okay, but do I have a constant of variation yet? I don't know until I test out the other 3 ways. So, looking at the second column, Jack, what goes up top? 120. What goes on the bottom? 4. What's 120 divided by 4? 30. I got another constant variation of 30. So far, so good. Works. Hagen, on the next column, the 150 and 5. Which one goes up top?
150.
150. And then what goes below?
5.
What's 150 divided by 5? 30. I got that constant again. But listen to me very carefully. Will you always get the same k value every single time? No. Sometimes will, a lot of times will, but not always. And I need to check it out one more time. Philip, for the last column, the 180 and 6, what goes up top, what goes below? And therefore 6, what's 180 divided by 6? 30. Do I have the same k value? Oh, do I have the same k value every time? Yes. That means I have, this is what you put here, I put yes, dv. What does dv stand for? Direct variation. Yes, I have a direct variation. What happens if I didn't get the same k value? You know what I would put? No direct variation. Okay, that's what you're doing there. Can somebody tell me how I should write my equation now that we do have a direct variation? So since I have a direct variation, how do I write my final answer under this? So this is part of it. It's good. There's
Y equals 30x.
What's my slope here? Matthew? 30. It's this number right here in front of x. Isn't it the same thing over here? Same thing. Drew, what's my y-intercept? 0. Yep. You guys got this? Yes, ma'am?
So you want your final answer like to always say y equals blank x?
If you say yes, I need to have this. If you said no, you can't get this because it's not the same. It has to be the same for all of them in that scenario. Okay. Let's do another problem, and then that's it. That's all there is to that lesson. Oh my. Look on 173. How many of you remember proportions? You guys remember proportions at all? Does that term mean at all remind you of anything? Like, reminds me of pain and suffering from cross multiplying. And then dividing. Okay, whether it gives you good memories or bad, it's very useful. So this is what I want you to do. I want somebody to read, first of all, example number 1 on page 173. Can someone read example number 1? Not all at once, please. Yeah, Alex, thank you very much for volunteering.
Brian's pay P as a lifeguard varies directly as his number of working hours age. If Brian's pay for 12 hours is 102, how much is his pay for 37 hours?
Okay, so that's the problem. What are the two variables they gave me? P and H, right? What does P stand for? His pay. What does H stand for? The hours worked. Okay, those are my two variables. Do you guys notice that they're not X and Y? Do you guys notice that? They're not X and Y. Do you get that? It's okay? It's allowed to do that, by the way. But one is independent and one is still dependent. So I need somebody to tell me, does your pay depend on the hours worked, or do your hours worked depend on your pay in this scenario? Because this guy's a lifeguard, Brian. His name is Brian. He works at some kind of water location. Yes, what do you have, Sam?
Pay depends on the hours.
Pay depends on the hours worked. How many of you agree with that? And I had the other class that were saying, but what about the hours? No. Pay depends on the hours, and I think most of us know it. What's pay representing then? Independent or dependent variable? Dependence. This is your dependent. If you need to put that up here, I'll put dependent right there. And what's your hours there for? Independent. By the way, you know what hours is also known as? Time. And time is almost always independent, right? Does that make sense? It's almost always independent, so there you go. Okay, here's my equation, y equals kx. That's my direct variation equation. And how do we find k again? What's that? How did we find k every time, basically? Yeah, k is found by y over x. Yep. So that's how we find our k value. Now, in the problem, it says Brian's pay varies directly as the number of hours worked. It is a direct variation. It is. But how am I going to use that to solve these problems? Here's what I want you to do. Okay. How many hours did he work the first time? 12 hours and he made $102. Is that what it says? Okay. Which number out of those two should go up top? The $102 or the 12? What goes up top? What goes below? 102 is his pay and $12 the hours worked. Is that y over x, by the way? It's y over, it is. But you're like, wait, no, it's p over h. Yep. Dependent over independent. Same idea. Okay, good with that. Now, they also gave us a scenario. What happens if he works 37 hours? So they gave me another ratio. Where does the 37 hours go? Top or bottom? It's only one place. On the bottom, because the independent goes on the bottom. But they didn't give me the pay. Do I know what the pay is? Nope. We'll call it P. Variable P. You can call it anything, by the way. Yeah. What do you think you're going to have to do here to solve for P? Cross multiply. Is this the only way, by the way, to work it out? No, it's not, but it's the way you need to get comfortable with. So what are you going to multiply first? 102 by, 102 by 37. Go ahead and do it, and I'll check you out if you got it right or wrong. 102 by 37. You may begin. Okay, did you get 3774? Okay, so I got 3774. And then what's 12 times P? It's just 12P. But that didn't give me how much money he's going to make. He does not make $3,774. That's not how much. It's too much. And if that is how much he's making, I'm going to take a job there being a lifeguard. Okay, But what do I have to do to solve this one? Divide both sides by 12. And it was cool because, we have our new student, and he does the math differently than you guys do, but it's the same process, just a different way of putting it. So I'll do it the way he did it because it was cool. And some of you already know it, I hope. So he puts the number there. Then he puts this bar there. Then he puts the other number there. That's weird, isn't it? Okay, but then this is how he actually does the math, which I think is very useful. It's short division. They do short division. Now, who does short division here? Short division? Okay. If you don't know how to do short division, that's okay. Do long division. But short division is nice. Here's short division. 12 goes into 37 3 times. So same thing. What's 12 times 3? 36. What's 37 minus 36? 1. Put the 1 right next to the 17. Some of you are like, no, not this. All right. 12 goes into 17 once. 12 times 1 is 12. 17 minus 12? 5. That's okay. 12 goes into 54 4 times. I know I'm going to have to use that out. 12 times 4? 48. 54 minus 48? 6. 12 goes into 60 5 times. You know why we call it short division? Because it's not long. You don't have to do all that stuff, but you can do that stuff. No. Listen, I'm going to tell you, I'm being honest not to make you feel good because I'm just being honest with you. Mr. A in short division, I struggled with that. Probably your age, I didn't know this stuff in high school because I'm like, how do you keep track of all those numbers? Hold on. Oh, I lost the number. It takes practice. And for me, it took me a lot of practice because I'm like, wait, 4 times 12 is 48. What was the other number? 54 minus, what did I get first time? See, I'm trying to keep these numbers and it's hard for me, but what did it take to get better? Practice. Okay, now it's not perfect, but it's better. Okay, but anyway, I got 314.5. That's not my answer. That's not how you write your answer. How much money does he make in 37 hours? 314 and 50 cents. 50 cents. That's how much this dude makes lifeguarding for 37 hours because he works with a direct variation. I see a lot of upset faces like, am I offending you by doing this? They're not going to be that bad, by the way. Be thankful. Okay. Back to 173, I want you to do number... for me to do with you, but just do this one on your own. Number 3. This is like a bonus one. Number 3. Okay, what did the instructions say on this problem? I want an equation of direct variation. Great. So that means my answer needs to be an equation that looks like this. I need to find what? I need to find the slope, which is our k. Good. Yep. K. Find our constant of variation. How do you do it? They only gave me x and y. Put the numbers where they belong. So what am I going to put up top? 12. What's on the bottom? 3. What does that equal? 4. What's my final answer? Y equals 4x. That's where that number came. That's where that equation's from. Now, listen carefully. They're not always going to be whole numbers. They could be fractions. That's okay. It's allowed. If they're improper fractions, change as the mixed numbers. If the numbers were both decimals, I'm going to have to do this. Your answer needs to be a decimal. So you have to divide out decimals. That's like 1 or 2. I think that's it. All right, homework. It's at that time already. Two through 18 even. 191, 180. All right, goodbye, Swivel.